Welcome to this explainer. Today, we're diving right in and unlocking Pixeva's AI text search. We're going to pull back the curtain on the multimodal AI and semantic vector search technology that is absolutely revolutionizing event photography.
Picture this. You're not hunting for obscure file names. You're searching for specific, complex human memories. Imagine typing something like wedding couple first dance or festival crowd jumping on beat directly into a search bar and getting flawless, perfectly matched photos back in milliseconds. It genuinely sounds like science fiction, right? Well, today, we're going to master exactly how this works under the hood.
Here is our roadmap for today. First, we'll cover the magic of AI search. Then, Step 1, deep image embeddings. Next, Step 2, language projection. After that, Step 3, cosine distance matching. And finally, we'll look at the future of event photos.
Let's kick things off with Part 1, the magic of AI search, and how we're moving far beyond basic metadata.
We all know the pain of traditional searching. It's that awful Sunday morning after a huge event where you're just hunting through unorganized folders, totally relying on manual tags, and just endlessly scrolling. Pixeva's semantic search completely shatters that workflow. By utilizing multimodal vector embeddings, we're entering a world where the system inherently understands the pure descriptive context of the scene itself. It doesn't just see pixels, it understands meaning.
To really wrap your head around this, you have to visualize what's called a semantic vector space. Imagine this vibrant, glowing, high-dimensional mathematical grid. In this space, every single photo from your event and every single word you could possibly type exist as exact coordinate points, and they're placed there purely based on their underlying meaning.
Let's get into the mechanics. Step 1, deep image embeddings, turning pixels into points.
This entire architecture is built on a strict three-stage pipeline: deep image embeddings, natural language queries, and finally, a cosine distance match. The whole process kicks off the second you upload a raw image.
Here is where the crucial conversion happens. We use advanced vision transformer backends and simulated AWS SageMaker models. So, instead of a photo just sitting as a file in a folder, its physical pixel matrix is instantly translated into a high-dimensional vector. The AI mathematically encodes everything: the lighting, the subjects, the action, mapping it perfectly as a coordinate into our glowing grid.
Moving right along to Step 2, language projection. This is where we turn words into math.
Let's say you type a phrase like festival crowd jumping. The AI doesn't do a text search for a file named festival. Instead, it projects your natural language search string into the exact same, identical embedding space as the photos to capture those complex visual relations. Effectively, your text just became its own mathematical coordinate.
Which brings us to the most important part, Step 3, cosine distance matching, the perfect alignment.
Okay, so now your photo and your text both exist as coordinate points in our high-dimensional space. To connect them, the system executes a cosine distance match. It is literally measuring the mathematical gap between your word vector and the photo vectors. It's that simple. The shorter the distance between the 2 points, the more perfect the match. Now, the truly mind-bending part of this entire architecture is the raw computational speed. This insanely complex distance matching happens in just 42 milliseconds. We're talking sub-50 millisecond inference time here. That is literally faster than the blink of an eye. Because the AI deeply understands pure descriptive context, the confidence scores for our simulated demo queries are just staggeringly high. Look at this. A query for wedding couple first dance hits a 99.8% accuracy match. Festival crowd jumping on beat scores 96.2%. And friends dancing together comes in at a solid 91.5%. These are incredibly high confidence matches, and again, returned in just milliseconds. Finally, Section 5, the future of event photos. Let's talk practical magic. All of this high-level math translates into tools that solve massive real-world problems. This exact same semantic vector technology allows you to find specific candid moments instantly. You can filter entire galleries by genuine, joyful emotions using the AWS Recognition Emotion Engine, which computes facial structures in real time. It powers the Auto Call Assistant, analyzing sharpness and elimination vectors to instantly toss out blurry or underexposed shots, saving you tons on storage. And it completely automates generating smart albums by clustering facial vectors for every single guest, requiring zero manual tagging. As we wrap up this explainer, I want you to think about how this technology completely changes our relationship with our memories. By taking the emotional, visual elements of our lives and turning them into these high-dimensional data points, we can ensure that no perfectly captured moment is ever lost in some forgotten folder again. So if an AI can instantly translate your complex human memories into a flawless mathematical coordinate, what specific moment will you search for next?